AI coding assistants generate software at incredible speeds, but rapid output hides structural vulnerabilities, and a fast build easily fractures relying on unverified code. Guardrail is a dedicated safety layer built precisely to catch the unique errors produced by AI coding assistants before they can ship. This comparison matrix shows where standard tools fall short. Guardrail detects AI-specific errors, like hallucinated imports and placeholder code, and executes structural autofixes that legacy linters miss. In this tutorial, we will set up a fully automated zero-configuration security net. Step by step, we will secure your code from the local terminal all the way up to the pull request. Writing thousands of lines of code in seconds only helps if that code is secure. Without an AI-native safety net, that speed becomes a massive liability. Step 1 is the initial deployment. In a standard TypeScript repository, Guardrail requires zero configuration to run its first scan. You install it, and it works immediately. Looking at this terminal output, you can see the baseline scan completes in under a second, while immediately generating a clear list of flagged vulnerabilities. The scan catches standard critical security flaws right away, identifying issues like SQL injections and hard-coded API keys left behind by a careless prompt. But standard syntax errors are only part of the problem. AI models introduce a completely distinct threat category known as AI anti-patterns. This flow diagram illustrates a common AI failure, hallucinating a non-existent ghost library. When the model imports a fake package or leaves generic placeholders, the execution chain breaks. Rapid AI refactoring also degrades code quality, leaving dead code that must be cleaned out. To handle this in an existing codebase, you can use the gradual adoption feature. This establishes a baseline that suppresses legacy issues, allowing your team to focus exclusively on securing net new code. Legacy linters simply do not look for hallucinations or AI-specific shortcuts. Relying on them to verify AI-generated output leaves your repository exposed. Pointing out errors is necessary, but Guardrail also resolves them using an abstract syntax tree, or AST, autofix engine. Here, the engine instantly rewrites a tangled, inefficient loop into a streamlined path, automatically clearing unused imports. However, the autofix engine has boundaries. When detecting complex logic failures like an N+1 database query, it safely flags the branch for manual human review. You can also handle these fixes directly at the point of creation by integrating Guardrail with the Claude code chat. Here in the chat interface, the user simply prompts the AI to run the Guardrail scan tool to evaluate the code it just wrote. The assistant parses the output, summarizes the detected security risks, and asks for permission to run the remediation tool. Once approved, the Guardrail fix command resolves the vulnerabilities immediately, without the developer ever leaving the chat interface. Moving this remediation step into the AI prompt interface neutralizes risks before they are even saved to your local file system. Now that the individual developer's local environment is secure, the next step is automating these checks across the team's repository. This terminal mockup demonstrates the built-in pre-commit hook in action. It acts as a physical barrier, blocking a commit because a hard-coded secret was detected. From there, you can configure GitHub Actions to automatically run Guardrail on every new pull request. This sequence shows the underlying protocol. Guardrail's JSON output converts into serif, the standard format for static analysis results, so GitHub can process it natively. Those serif packages translate directly into clear, inline security annotations exactly on the lines of code in your pull request diff. Automated CI/CD checks enforce these security standards across the entire repository, providing consistent oversight for every developer on the team. This creates a complete, multi-layered defense system. The protection flows continuously from the local terminal, through the AI chat, and straight into the repository. Because deployment requires zero configuration and the local scans execute in under a second, you add no friction to your daily workflow. Development speed and code security do not have to be opposing forces. With the correct defenses installed, your team can utilize the massive speed of AI code generation without risking a catastrophic vulnerability. Check the video description to copy the installation command and review the documentation to set up your gradual adoption baselines today.
Please like, share, and subscribe.